Welcome, ladies and gentlemen. My name is Giacomo Fiocchi. I'm the e-Power System Director of Carraro Group, and today I will guide you through our new project called Hard Mild Hybrid, an electrified powertrain that it's installed at the moment on our specialty tractor for vineyard and orchard application. e-Power Systems is born from our experience on our heritage based on gears, on driveline, axle and transmission, till the final vehicle like our specialty tractor. We are using our heritage in order to make an evolution and open to new products and services, focus on this blue E that stays for electric, electronic, electrified, till evolutive project of Carraro Group. Hard Mild Hybrid is born thinking to our specialty application, but today we are working also on other sectors like construction. Today I will guide you through the specialty application on our compact tractor. First of all, we are talking about an ecologic solution. So we are really focused on emission, and as you know, stage 5 regulation is very severe on emission limits. This is the reason why on combustion engine greater than 55 kilowatt, today it's a must to have an SCR, so a really complex after-treatment system that impacts on the heights from the ground of our tractor. This is the reason why we introduce a downsized engine, so 55 kilowatt instead of 75, and we are going to compensate with an electric motor. At the same time, we are giving a really interesting support in the transient phase where emissions are really huge, especially for the NOx. So we are saving the geometry and the size, that is a must for specialty application, and we are also compensating problems related to the emission. Why hard mild hybrid? Everyone knows the concept of mild hybrid coming from the automotive. Here we are talking about hard mild hybrid because the contribution coming from the electrified powertrain is really consistent. So the tractive effort of the machine, the entire operation of the machine is really and heavy supported from the electric motor. This is the reason why we are talking about an extended range in terms of power till 20 kilowatts. So hard mild hybrid compared to the standard one. You can see in the graph there's a contribution in terms of fuel saving that is really consistent. And today I'll guide you through the result of our field campaign using our tractor. Let's have a look to the architecture. As you can see, there's a battery based on nickel metal hydrate chemistry in order to avoid any inflammable and explosion situation that support the electric motor. Electric motor is connected through a belt with the combustion engine, so the combustion engine and electric motor are always linked together. The electric motor works on both directions, so it gives support to combustion engine, but it can also recharge the battery during transient where the power is less than 55 kilowatt. We are talking about a P0 architecture, but I would like to give you directly the picture taken from our tractor. Here you can see here in the workshop some of the parts installed on the tractor. In the front you will see the permanent magnet electric motor, completely air-cooled motor to avoid any impact in terms of installation. And then you can see in the front also the power electronics under the electric motor, and in the back of our tractor the battery, 1 kilowatt battery. The size of the battery is really linked to the application. So as you can see here, the logic, the boost function working this way. As soon as starting from point 1 we start to increase the load for the combustion engine. The risk is that as soon as the load will be too high, the engine speed will start to decrease. So from number 2 we can reach also number 3. So we have a really consistent engine overload. As soon as we pass a threshold that could be set through the software, the electric motor starts to run in order to support the combustion engine, avoiding the overload. And the speed will come back to the target. I would like also to spend a couple of words about the battery. The size of the battery is sized for our application. It takes 2 minutes, for example, to make a complete discharge from 80% state of charge till 20% state of charge. So we have a complete boost function in this scenario, and the time needed to recharge completely is 4 minutes. So starting from 20% state of charge till 80% state of charge, it takes 4 minutes. We started from our historic data, so we have a lot of data. Data is the base in order to take the right decision, to develop a consistent algorithm. And from the data, we start to make a model, a virtual model of each component, electric powertrain, combustion engine, the entire systems together. We start the iteration on the model, and then we move to the bench. With the bench, we are able to characterize the electric motor behavior, the charge and discharge cycle. So we have the entire mild hybrid kit installed on the bench. And then we arrive finally in the field test. So in the field test, we are able to see if all targets are satisfied. You can see in the left side of this slide the duty cycle of our application. This is a specialty tractor, so this is the standard duty cycle that we use for this such of tractors. Today we'll be focused in our testing campaign on the traveling, sprayer and cultivator operation. So heavy operation where the power needed is greater than 55 kilowatts. So we make a focus on the heaviest scenario for our tractor. We are comparing three vehicles at the same time in the field. Our standard compact, that is a 55 kilowatt combustion engine. We are comparing our hard mild hybrid on a compact tractor, so a 55 kilowatt plus 20 kilowatt coming from the electric motor. And we are also using a 75 kilowatt internal combustion engine to have the complete scenario and a really consistent comparison application. 10,000 hours is the lifetime of our vehicle in this testing campaign. So you can see here the percentage, 50%, 25% applied to the total of 10,000 hours. You will see the number of hours for each of the application that we are testing. Let's talk about the results. You can see here different type of application, static performance. We measure the power of our combustion engine compared to the hard mild hybrid. You see the kilowatts and the performance that's similar between the pure combustion 75 kilowatt engine with this hard mild hybrid. But then let's focus on the three main applications. The first one, traveling with a trailer behind. We also inserted a hill in order to simulate mountain application. The time taken to reach the top of the hill is more or less the same if you compare the hard mild hybrid and the combustion engine 75 kilowatt. Obviously, it takes too much time, the pure 55 kilowatt combustion engine. If we move to sprayers, we measure the average speed along the operation. And you can see here that also in this case, the average speed, if we compare the pure combustion 75 kilowatt with our mild hybrid, are exactly the same. And in the cultivator performance, we also measure the speed. And you see there's a benefit in terms of vehicle average speed because our mild hybrid increase of 6.9% the vehicle speed during this such of operation. Let's make some focus, not only just measuring the pure performance in terms of number, we want to highlight some fact. The first one, that using our hard mild hybrid, the vehicle speed is really constant. You can see here that in the first diagram, the blue one, the speed is really constant compared to the other scenario. And there's a benefit, for example, in terms of comfort from the driver perspective, because the speed is constant, the comfortable, it's very good inside the cab. And also, if we look at the hill performance, you can see that the time taken from our tractor compared to the 75 kilowatts is the same to reach the top of the hill, but the reaction, the readiness of our tractor is higher. So in the first meter, the reaction and readiness of our hard mild hybrid is higher, the blue one, the blue line, compared to the other two vehicles. We made also a simulation on a sort of infinite hill. So starting from a state of charge 85% till a 20% state of charge, so a complete boost function, how long can we travel in a speed? We are able to cover 422 meters in a speed with an inclination higher than 28%. So it's really huge application that we are able to cover with a complete boost function of our hard mild hybrid. Let's talk also about fuel saving. Fuel saving is one of the key topics of our application, and you can see here in this table a lot of number. We measure all the liters that were consumed in all the application, refilling completely 100% the fuel tank, and measuring the consumed fuel. So we are talking not about simulation or electronic data. This is the real fuel used from the vehicles in all the application. We are just considering the three most heavier applications, so the traveling, sprayer, and cultivator. We consider neutral the impact in the other operation like idle or light duty, but we know there's a benefit anyway, so we are more conservative in this case, and we measure a consistent fuel save reduction. We have also to keep in mind that avoiding the introduction of the SCR, we won't use the AdBlue. So the total fuel save diesel plus AdBlue will lead us to a saving close than 90%. It's a big number that, if we consider also the cost of the entire powertrain, comparing the pure 75 kilowatt engine with our mild hybrid, this saving in terms of fuel and AdBlue will compensate the extra cost installing all the electric and electronic devices for our mild hybrid. So we are talking about a solution that also from economic point of view is absolutely sustainable, because we are avoiding to install SCR, that lead cost. We are increasing the cost because we are using a battery, we are using power electronic and so on, but at the same time, in the entire life of the vehicle, we are able to rescue the extra money used to install the mild hybrid kit. Let's make up a resume. So here you can see in the blackboard all the major topics that we want to highlight. First of all, there's a cost-neutral application. So for the first time, we are talking about an electric application that also from economic perspective is really interesting. And this is the first point, because our mild hybrid will help OEMs to make a jump into the electrification in a really moderate and sustainable way. Second point is we are able to use this solution, this such of our mild hybrid kit, with any combustion engine. So there's no impact on the combustion engine side in terms of thermal behavior, in terms of electronic interface. We are running in parallel together with the combustion engine, and we are able to switch to any type of engine. Obviously, we used our 3-cylinder because it's a really compact application, and there's a benefit because we are downsizing the engine from a 4-cylinder 75 to a 3-cylinder 55 kilowatts. Total system efficiency will be increased at 3%. It's an interesting value with this such of architecture that is very simple and neutral in terms of installation on the tractor. And also there's a big benefit in terms of cost saving for the fuel and the AdBlue, because as already said, we are close to 90%. Carbon footprint, very important for us, and also our sustainable roadmap. With this such of solution, we are able to save 10.3% in terms of CO2 reduction in the entire life of our tractor. And also from the maintenance point of view, the effort is comparable to a 75 kilowatts. We are working with a battery that is able to survive for the entire life of this tractor, for the 10,000 hours. The complexity of the electric motor is not so higher, and it doesn't need any extra costs compared to the maintenance of a combustion engine. Consider that on the combustion engine of 75 kilowatt we have the SCR with some dedicated service, so there's a neutral, it's neutral the comparison between the two solutions. And the last point, better performance. First of all, vehicle speed. The vehicle speed really constant helps the customer for a comfort perspective. The readiness tractor give us a feeling in terms of reaction that it's very appreciated. And also, if we have to think about vehicle speed, there's a benefit also in the entire operation of the vehicle, also from an implement perspective. So let's us say that this is the first project that is close to be produced. At the moment, we are close to be with some of our customers in the field, also collecting their feedback. Our mild hybrid is a way to jump in a moderate way in the electrification, as already done from the automotive. Thank you very much for your attention.